Uh, so uh, a four-term sequence is formed by adding each term.
Yes. No, what
So
I was asking is, so a four term arithmetic sequence, I will have only four terms, right? So I have this much only, a plus 2d and a plus 3d. So up to this much I only have, right?
yeah.
So this is a four term arithmetic sequence, right? So similarly, I have to consider a four term geometric sequence. So I have to use something else, different letter. So let us use br square, and br cube, right?
Right.
So now they are what they are saying. So you have to form a new sequence by adding each term, right? So you have to add these two
A
terms.
plus
I have to
B, yeah.
right. So this is my new sequence. Okay, tell me what will be my new sequence if I add them,
So A plus B,
right?
A plus D plus BR,
Right.
A plus 2D plus BR squared,
Okay.
and A plus 3D plus BR cubed.
Right. So this is my new sequence, right?
Yes.
Okay. Now let us see what else information they have given. So they have said that the first three terms of the resulting four-term sequence is 57, 60, and 91. Right.
So
So
I'm wondering, can I solve this like system? Like,
yes, yes, that is what you have to do. So the thing is 57, 60, and 91, right? So this one is 57, right?
right?
This one is 60, and this one is 91, right?
Yeah.
And they have asked you to find the fourth term. So this is the question, right?
Right.
So yes, you have to solve the system. That is, of course, because there are three unknowns, or in fact, there are four unknowns. So A, B, D, and R, right? But you have only three equations, so you have to solve them.
Hmm.
Yes. So how to do it?
So you can first write the equation A plus B equals 57, and
Yes.
then you can find that A is equal to 57 minus B.
Okay. Okay. Let me write down. So this gives you A equals to 57 minus B. Okay. Then.
Uh, then you can uh, then you can take the two 60 and 91 and say D plus BR plus 31 is equal to A plus 2D plus BR squared.
Mm, okay. Okay. I means you are replacing A in the second equation and the third equation, right?
No, no, no. Since A is in both equations, it would be canceled, right?
No, no. Which so you are using the second equation and third equation, right?
Yeah.
Then what are you doing?
I'm adding to the second equation 31 and then solving.
Okay. Okay. I understand what you're doing. So you are saying that A plus T plus BR plus
Plus
31.
1 is equal to A plus 2D plus BR.
Yes. So A will get cancelled. So one D will also get cancelled. So
BR plus 31 is equal to, yeah.
right. So how it will help?
Then you say AB plus 3 is equal to AD plus BR.
Okay.
Uh, so then, yeah, B plus 3 is equal to B plus BR.
Right.
And then you can You can say b minus d plus 3 is equal to br, and then
Okay, but okay, you're trying to replace BR, right, from the
yeah,
these two equations.
yeah.
Yes, that you can try. But what my observation is, we can replace D, right? That is easier, right?
Oh, right, right. D is definitely easier.
Right. So from here I get D equals to minus BR, right?
Right.
So what I can do is
br plus 31 is equal to b plus 3 minus br plus br squared.
okay. So let us do one thing. Let us bring all the integers to one side and all the variables to one side, right?
Yeah, so br squared minus 2br
Right.
minus plus b minus 28.
Yes, we can keep the 20 on the other side, right?
Yeah, that's fine. Uh, then you can you can I think you can keep the b on the other side as well and factor br out, right? Or no?
Yes, B we can take common, right?
B, right?
So that give you R minus 1 whole square, right?
Yeah,
Okay. So yes. So now, so this much you have, right?
right,
But this thing is, yes. Now you have to do case work. I mean, since there will be multiple options. Means at least for now, at this stage, there will be more than one option, because I don't have a definite equation of B and a definite equation of R, right?
right,
Right. So what I can do is, so this is 4 times 7 times 4, right?
right.
Or I can take it as 20 times 1,
Okay,
right? Because so this thing is a square quantity, right? I have to something whole square I have to keep, right?
right,
So either it is 2 square or it is 1 square. Anything more I cannot take, right? So there are two options. So from this, so the case one is that r minus 1 whole square. So this is 4. So this gives you r equals to,
oh, then r is equal to 3.
right? So r equals to 3, and you have b equals to 7, right?
Right,
So if b equals to 7, then you have to now find what is our a and d we require, right? Because b
right.
and a and d we require.
So
So
a
that
is
is,
50.
yes. So a plus b is 57. From that I can get easily.
Yeah.
A is 50. What about d?
What would be, can you scroll up?
Yes, d also we got, right? B plus 3 minus br, right?
Yeah,
So that we can use. B is 7, 3, br is 21, right?
yes.
So d is
D is negative 11.
negative. Okay.
Uh,
Okay. So okay. So now we can
you
construct
can
our,
you can check whether the never mind, never mind.
yes, yes. That is the thing. Well, you have to check whether it is a valid solution or not, right?
Yeah, that's it.
Yes. So what are the things I have? A is 50. D is minus 11. So what will be the arithmetic sequence?
Uh, 50,
Right.
30, 50, 39,
Right.
28,
Right.
17.
Right. This much. And then you have your geometry sequence. So that the first term is B, right? So it is 7 and R is 3. So
Yeah,
7 then.
21,
Hmm.
63,
Right.
189.
Right. So now I have to check whether it is working or not. So we were adding them. So 57, that is correct. What is
60,
39?
60,
Right. Then
91,
right.
and 206.
206. Right. So hopefully this will work. So this is working. This is our answer. But let us check case 2. What happens to that one?
Um,
So the second case is
so case 2 is b times r minus 1 squared is equal to 28 times 1. Uh,
yes. So
so,
this is one here.
so b is equal to 28.
Right. B is 28 and R is 2. Right. What will be A then?
What?
Give up.
A will be, yeah, A will be 29.
Right. And D.
Uh, so it's B plus 3 minus BR. So
Right.
31 minus 56. Negative 25.
Right. Now let us try to construct the arithmetic sequence. A is A and D, you know. So
So 29,
hmm.
uh, then it would be 34. I mean, yeah, no, not 44.
No, no. Negative D. D is negative 25.
Oh, 4, sorry.
Right.
I'm confused. Then it would be negative 21,
Right.
negative 46.
Right. This is what is the geometric sequence?
That would be, uh,
Sorry, 28.
yeah, 28, 56, 112, and 224.
Right. So is it working? What is the first term? If we add
57,
right,
60,
right.
uh, 91.
Okay.
The last one is not, it's not the same. Uh,
Yes, that is fine. That can differ, but we have to see. Okay.
that would be 189. No, not 189. Sorry, 188. Sorry.
178.
Oh, 178. Okay,
Check once. It is 178, right?
right, 178.
Right. That will be different because the thing is our conditions are different, right? So that will differ. That is obvious. That will differ. But the thing is, we will have one answer. Why? Because we have they are given one more condition that you have to focus on the question, that they are saying that the fourth term arithmetic sequence of a positive integers. The arithmetic sequence will be of positive integers. So the second case will not work because
Right,
here we have negative integers.
right. So I'm a little bit confused
Yes.
about the case. You said the case 1 and the case 2, right?
Right.
So you took you so you so because all the answers have to be integers,
Right.
so you assumed that b no, not b times r. What was it? 28
This
would
is
have
this
20,
one, right?
yeah, 28 would have to be cut into uh uh 28 times 1 or 7 times 4 for the roots.
Yes, yes. That is only possible, right? Because you have the integers, right?
Okay.
Other than that, we don't have any factorization, right? Because the thing is, I want this part is a perfect square, right?
Right.
So the perfect square, these are the only two options for my perfect square in the 28, right?
Okay.
Yeah. So these are the only two cases. Yes. So why case two will not work? That is clear, right?
Right.
Because these are negative integers, but in question they are asking for positive integers, arithmetic sequence of positive integers.
Right.
Okay. So our option is option E, right?
Yeah. Option E.
Right. Okay, so I think this was which problem it was? 20, right?
20.
Yes. Next, which one you have doubt?
Uh, I think it's the next one, 21.
Okay, 21.
I think that as I do the test, the problems become much harder.
Yes, yes. The latter problems are usually harder. Means after 15
Yeah.
or something, the latter problems are usually harder. Yes. So 21, right? Next one.
Yeah, it's some bowl shape.
Right. Okay, so yes, that will come. But before 20, the remaining problems you could do. Before 20, all the problems.
No, I went over them by myself and I figured it out.
Yes, means you could do, right? All the problems up to 20.
Uh, some of them I had issue, but I fixed the issue.
Okay. So let us do problem 21.
But all the ones from 20 to 25 were difficult.
Yes, yes. So usually that is the case. From 20 to 25, they give some tricky questions. Okay, let me copy the question. Yes, you can see, right?
Yes.
Okay, let us understand what they're doing. So a bowl is there that is found by attaching four regular hexagons, okay, of side 1 to a square of side 1.
Right.
Okay. Okay, so this is our square, right? I think this is a square, right?
That's the base. Yeah.
Right. So this is the hexagon, right? The edges of the adjacent hexagon coincide as shown in the figure. So this edge is coinciding, right?
So they're the same length.
Right. Length is all same because side 1, right?
Oh,
So that is given. So what is the area of the octagon obtained by joining the top 8 vertices of the four hexagons? Situated. Okay. So this thing they are asking to find out, right?
right.
Okay. So the thing is to find the area of the octagon, we have to find the side lengths, right?
Right. Are the sidelines just one?
No, no. Yes, that we will figure out. But the thing is, this side length I know this is one, right? Because it is the
Okay.
hexagon. Right? This is one. This is one. So and this one is also one. But this part I am not. It is not clear what is the side length because this does not come from the hexagon, right?
Can you assume that that angle right there is right angle?
Which angle?
The triangle, the angle in the triangle.
Yes, yes. This one.
Yeah.
This one
So
is right angle.
so could I say that's one root? That's just root two. That side is
Right.
root two,
Yes, yes. That is the thing. So this is the right angle, and I know that these two things are one. So this will be root two. Right?
and then it's just a combination of root two one, root two one, root two one.
Yes, yes, yes. Though yes, but the thing is, okay. Let me think. Will it alternate? Yes, yes. It will alternate, right? So the
Right.
thing is, this is root two. Then it is one.
Yeah.
So this is one, and this is root two.
Right.
Right. So yes. So this is our octagon. So the side lengths we have found out. So now what will be the area? How to find the area?
So so you can divide it into 8 triangles, or
Okay. Okay. Let us do it in a plane. That will be easier. So let us try to draw an octagon here.
right. Doing it here will be easier.
How many sides? One, two, three, four, five sides we have drawn, right?
7 here.
It is not perfect, but okay. I think this will work.
Right.
Okay. So let
So the
us
so the, yeah. So the non-straight sides are root two.
right.
a slanted line.
Now, how are you trying to break it into triangles?
So you can draw a line from the center of the root 2 lines to make like
Hmm.
an X in the middle. Just
1 minute. Let me try to understand. So this you are saying this line?
uh yeah,
Okay. Okay then.
and then the other side from
Yes. So this, right?
right,
Okay. So how it will help?
and then you draw a line from uh one from what was it? You draw a line from
Okay, I understand. So this one, let us name it. Then it'll be easy.
yeah. That would make it easier. Is there a way I can like annotate on your screen?
You have some pen type of thing,
Uh, I do have a pen.
like
I have
what
I
you have?
have a start pen.
Oh no, I think so. This is I am doing on my iPad.
Oh,
So
okay.
so yes, you can tell. I will write down. That is easier.
Okay. So, you can do a point from G to C,
Okay. I think it should intersect at the bottom. My drawing is bad. Anyway, it should
and
intersect.
D to H.
E to H. Okay. E to H.
No, D.
D to yeah, right. D to H. Yes.
So now it should be 8, right?
Uh, e- no, there are 8 triangles that you are saying.
Yeah.
Yes, yes, there are 8 triangles. Yes, so this should be a common point. Yes. Then how to find the area?
Oh, we can't use sine or cosine, right?
That will be difficult, right? Something
Yeah.
easier, can you think? So because sine, cosine, or how do you want to use? Because the thing is, these angles are not equal, right? Because the side are not equal. So the side lengths are different. So the angles will be also different, right?
Right. That won't work.
So that will be complicated, right?
Yeah. I
So
forgot there's a slightly easier way to do this.
yes, tell.
I'm trying to remember.
Yes, think about it.
Uh could you make trapezoid?
Trapezoid. How to make it? Okay, let us make a
Or
same shape.
draw a line from A to F.
Okay, just give me 1 minute. I don't know whether I'll be able to capture it. Okay, it is not coming. But anyway, yes, tell me. So which lines? So inside lines, I'm then erasing, right? Like
Or you can maybe make a square around it.
okay.
Um
So around it means okay. Let us. So inside lines, I'm erasing. Okay.
yeah. You can maybe make a square on the outside.
Okay. So like this, you are saying.
Yeah.
Okay. Okay. Then
This seems slightly easier.
yes,
Um
that will be easier. So then how to compute? Tell me.
so the hypotenuse of the triangle there is root 2,
Right.
since because of the 45 45, uh
Yes.
if you put if you, those side lengths next to F, G, all those other side lengths that aren't labeled
Hmm.
would be 1.
Right. These are ones. Yes.
So the area of the giant square would be 9.
Right. So that is side length is 3. So
Yeah, and then you subtract the square root of 2 divided by 2, because it's a triangle. So no, not square root. No, it's just minus point 0.5, uh 0.5 times 4. So minus 2.
right. So it is half times 1 square. Right.
Yeah, so minus 2.
Right. 7.
That
Right.
right.
I think that is the answer. So it's B. Right?
Is it 7? Mm, okay, yes, it's 7.
So this is fine, right?
Yeah, this one I thought this one is. Yeah, it took me a little bit to realize that the thing was a right triangle, so I could use the rule to make square root of 2.
Yes, yes.
Can we go
Okay.
over 22?
Yes, yes. 22 you can do. Okay, let me copy the question. So this was problem 21, right?
This is problem 20.
Yes. So they're saying,
So,
suppose there are 13 cards, that is 1 to 13, they are numbered, arranged in a row. The task is to pick them up in a numerically increasing order, working repeatedly from left to right. Okay. So for example, uh, the 1, 2, 3 they are picked in the first pass, right? So then if you pick 1, 2, 3, then in the next pass, what will be the ordering? So this 1, 2, 3 is gone. Then you are left with 4, 5, right? Because 6 you cannot do, because 6 is not in the ordering, right?
right,
So 6 will come in the next pass, right?
right,
So yes, so then 7, 8, 9, 10, because 1, 6, 4, 5, 1 and 2 is gone, 3 is gone. So then what is the set? The 6, 7, 8, 9, 10 are in the ordering, so I can take in the fourth pass, right?
right.
And then the remaining 11, 12, 13 on the fifth pass, right?
But does the fourth and fifth pass really matter if they're just asking about how many can be picked in 2 passes? We just know that those numbers are gonna because you have to
No, no,
pick.
no. They just explaining for this example.
Okay, okay,
So the thing is, they are asking that the total possible orderings is 13 factorial, right?
right.
So because you can arrange them in 13 factorial ways. So the thing is, for how many of these 13 factorial possible orderings of the cards will the 13 cards be picked in exactly 2 passes? Yes. So that is the question.
So will 13 cards? So all cards picked up in 2 passes?
Yes, yes, all the cards should be picked up into two passes. Okay, so let us see the problem in a lesser number of cards. So 13 cards is a big number. So suppose you have 5 cards, right?
Right,
So let us see the problem in a smaller quantity. So you have 1, 2, 3, 4, 5. So these are the card numbers.
right,
Uh, okay, so now we have to see which arrangement will give me. I can pick all the cards in 2 goes, 2 passes, right? So suppose I arrange like this. Suppose one, two, three. I like arrange this one and I arrange 4, 5 like this, right? So in the first pass I can choose 1, 2, 3, right? And in the second pass I can choose 5, 4, 5, right? And I'm done.
right.
So this arrangement will work, right? So like this, they are asking that how many of this arrangement of these 13 cards out of these 13 factorial arrangements.
But it's so. But on the third pass, you can only. But on the first pass, you're not able to pick 7, 8, 9, right?
Mm, 7, 8, 9.
Yeah.
No, no. Yeah, in this example, what they are given, we are requiring minimum. These 5 passes are required. We cannot do in 4 passes. Means 2 passes. So in this example, what they are given, we need 5 passes to pick all the cards.
Right. Wait. So I'm just curious. So if I so if I were to take all of this, like, how could I fit more than 3 cards in a pass? Like, how could I start with 1, 2, 3, 4, 5?
No, I did not understand your question. Tell again.
So how does it? I don't really understand how the passes work. Like,
Yes, yes. So, okay. So, okay. So let us go through the example once again. Means I am trying to show you in a shorter example, not with 13 cards. Okay.
okay,
So suppose you have 5 cards.
yeah,
Okay, let us take 6 cards. I will take something. Okay. So then, suppose I have a random arrangement. So let us take. Right. So this is the arrangement of the card I am given to us. Right.
okay,
So the thing is, what do you mean by picking up pass? The thing is, so you'll start looking at one, right?
right,
And I check the increasing order. So after one, two is not available, right? After one.
right,
So in the first pass, I can only take out one. So then I am left with two, three, four, five, six. So I can take out one only from the first pass.
okay.
Not clear, right? Is it clear or not clear?
So only cards to the right can be picked up.
Yes, yes. So I can only pick out cards that are in an increasing order. So, so instead of this one, suppose I had this ordering.
So in the example above, why can't I pick up 1, 2, 3, 4, 5 in the pass rather than 1, 2, 3?
Yes, yes. So the thing is, one, two, three. This is in an increasing order, right?
Yeah.
But after that, four, five is before one. So that is not in an increasing order, right? So I cannot take out four, five in the first pass.
So I understand now. Okay, I understand.
Yes. So once this one, two, three is gone, then what will be in the second pass? What can I take? I have to start with four. So I can take only four and five, right? Because anything after that is before four, right? Four, five, six is before four, so that I cannot take.
Right.
So in the next pass, I can take four and five only.
Okay. So what I'm thinking here is that can't you can't you have see you can have even one number. You can have like say 2,
Hmm.
or no, you can have 13 at the end, right?
Yes, 13 I can have at the end. So,
And then you can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and you can
hmm.
pick all of those up in one pass, and then you pick 13 in another pass, right?
Means 13 in the end means in the first position you are saying, right? Or which end you are saying 13? So
See,
like this you are saying?
yes, yes, yes.
Yes, yes. This I can do in two pass. I can take all of them in the first pass and this one in the second pass.
Okay, that's one possible arrangement.
Right, right. One possible out of this 13 factorial order things.
See, I don't know how to approach this because I only see a couple possibilities, and the answers are saying that there's so many possibilities.
Right. Yes. Yes. You cannot manually calculate all of them, so you have to find a way to find. Right.
Yeah,
So yes, the thing is, yes, more or less what we understood from the problem is we have to do in two passes, right?
right.
So the thing is, the bunch I should have arranged the numbers in such a way. In the first pass, I get a slot of numbers, and in the second pass, all the remaining numbers I can pick out, right?
Yeah,
Right. So the thing is, so 1 to up to 13, I have to break them into two parts, right?
right.
So I have to break them into two parts such that I choose the first thing, means this first number of cards I can take in the first pass, and the second set of cards I will take in the second pass. So that is how should I break the number, right?
Right.
Okay. So how to do it? So suppose I break up to k, and the second thing start from and the second thing start from k plus 1 up to 13, right? So it can write 13 also, right?
But these numbers are both like these numbers are intertwined in the.
Yes, yes, these numbers are intertwined in the arranging, but
Yeah.
this is not my arranging. This is
Right.
not my arrangement. So this is the way how I want to choose,
Right.
right?
Yeah. Yes.
So that the thing what I want to say is in the first pass, I want to choose 1 2 up to k, right? And
Right.
in the second pass, so I want to choose from k plus 1 up to 30. So this is my aim,
Right. I understand this.
right? Now k, where can k vary from? So what is the
K can be from 2 to 12.
not 2, right? 1 to 12, right? I can have 1 in the first one only, right?
Oh, right. 1 to 12.
Right. So k will vary from 1 to 12. Yes, because we need at least one card in both of them. So k is from 1 to 12. Yes.
Right.
Yes. Now how to do it, that you have to think. So the thing is, so there are 13 slots, right? How to arrange? So these are the 13 numbers, 13 slots, and you have to arrange these 13 cards, right?
Right.
So the thing is, arrangement is done because I have to set them in an increasing order, right? Then only I can choose them in a one go, right?
Right.
So for this k numbers, this 1 2 up to k, how many ways I can choose from these 13 numbers?
Uh, 13 factorial.
No, no, 13 factorial is the all possible arrangements. The thing
Yeah.
is, I want to choose k positions out of these 13 positions, right? For these k numbers or k cards.
Right.
So how many ways to do it?
12.
No,
13. Sorry. 13.
no, no. Think about it. So do you know this thing? A binomial coefficient, you know? Binomial coefficient and those things, you know?
No, not really.
Oh, okay. Then I think it is like, okay, let me write. This notation have you seen? In choose k, this one?
Uh, I think so. So it's like n factorial divided by n factorial minus k factorial times k factorial.
Yes, the definition is correct. So it is k factorial times n minus k factorial. But what does it mean? Means in
So it's like so n choose k.
yes, means what does it mean? Means commentarily, what does it mean? Means what does in
You
physical relevance? What does it have?
so you can choose k numbers from n positions. I don't
Right,
know.
we are choosing k positions out of n positions. Yes, that is the
Uh,
thing, right?
k
So
positions.
here the same thing, right? So from these 13 positions, I want to choose k positions.
Oh, so 13 choose k.
Right, 13 choose k, but 13 choose k. But the thing is, but all of the arrangement will not work, right? Because which arrangement will not work? Can you tell me out of this 13 choose k arrangements?
12, right? No, not
No.
uh uh 1, right?
Yes, which one will not work? One will not work. Yes. Which arrangement will not work in this thing?
Which arrangement? If you have if I don't understand.
Okay. Oh yes. Let me explain. Try to explain once more. So 13 choose k is you understood it. What is this 13
Right.
choose k?
Right.
So 13 choose k is the number of ways I will choose k positions out of these 13 positions, right?
Yeah.
So those k positions I will assign 1 to k, right? This like in an increasing order, right?
Yes.
But if I choose all the positions from the first only, so if I choose all the positions like this only, means 1, 2, 3, k, right?
Right.
Then that arrangement will not work, right? Because then I have to remaining I have to fill up with 13, right? K plus 1 up to 13.
And then it'll be one pass.
Yes, yes, that will be gone in one pass, right? So that will not work, right? So from here I have to subtract 1. So that condition I have to subtract,
Okay.
right?
Right.
Right. So this thing is thing. But now the thing is now we have to vary our k. So k can vary from 1 to 12.
Right.
So the total number of ways is the summation k equals to 1 to 12. This thing.
Okay. So
So yes, how to find this one?
I
So
mean,
this, so at least this minus 1 will become minus 12 because there are 12 minus 1s, right?
yeah.
So only thing is left how to compute this one. So this one there is an identity. Do you know that?
No, is this like calculus?
No, no, not calculus. Just basic your binomial. This coefficient. This in choose k there is an identity.
No, I'm not familiar with it.
Okay. Okay. So let me ask you one thing. So where have you seen this identity? In what context have you seen this identity?
Combination?
Okay. Okay. That is fine. But have you? So do you know this binomial theorem? Do you know what is a plus b power n?
Uh, yeah, I learned it somewhat with like Pascal's triangle.
Yes. Yes. What is that? Do you know?
Not really.
Okay. Okay. Let us do for smaller things. What is a plus b whole square?
I mean, I guess it's like the coefficient. It's not the coefficient, but like the power. Like
Hmm.
it it's the co it it's n is the coefficient, or
Not exactly. Okay, means I will get it, but you tell me just quickly what is a plus b whole square?
uh a squared plus b squared plus 2ab.
Okay, I will write like this. So there is a reason. What is a plus b whole cube?
3a and yeah, 3 no a cubed
Hmm.
plus what would that be? That would be 3ab.
3a square.
Oh, 3a squared b plus 3b squared a
Yes,
plus uh b
b cube. Right. What about power 4?
a to the power of 4
Right.
plus oh, this one's gonna be hard to.
Yes.
Would it be like 4a cubed? No,
Right. 4a cube b
4a cubed b
plus.
plus 4b cubed a.
Yes, that term will come. So this is a b cube and b power 4. There will be another term that will be a square b square. What is the coefficient?
Uh, 4,
No,
2.
no, no, no. It will be 6. Okay, so this is how you get the Pascal's. This is the thing you get from the Pascal's triangle, right?
Oh, right. The coefficients, right?
Right. So this 1 and 2 sum up to 3. This 2 and 1 sum up to 3, right?
Right,
So this 3 and 3 is summing up to 6. So this 1 and 3 is summing up to 4, right?
right,
So this is how we get, right? So the general expression also one observation is you can see that the power of A is slowly decreasing 4, 3, 2, 1, 0, right? And
right,
power of B is increasing 0, 1, 2, 3, 4, right?
right.
Okay. So the thing is, okay. So then in general, what you can do is, so a plus b whole power n. So it's a power n plus this term is n choose 1, a power n minus 1 b, and so on, n choose n b power n. So that is the general expansion.
Okay.
So this the coefficient of these things you get by the binomial coefficient, and these are the actually the terms of the in the one row of a Pascal's triangle. So this is 1 2 1 1 3 3 1 1 4 6 4 1. So this is a particular row of a Pascal's triangle.
Right.
Okay,
Wait. So can it should it be 2 to the power of n?
which one?
Like for this, could it just be 2 to the power of n minus 12?
Yes, yes. That will come. But the thing is it starts from, so the coefficient more, this is n choose 0, right? The first one is
Right.
right. So the thing is here that 0 is missing. K is starting from 1.
Right.
Okay. So what will happen? So how to adjust that?
So you just start with k equals 1?
Yes, K equals to 1, then you don't have the formula, right? So also it is ending up in 12 because here it ends up in n choose n.
Yeah, so
Let
can
me,
you make it from 0 to 11?
mm,
No, no.
no. Okay, let me write down in the next page with clear. So what we are trying to find is k equals to 1 to 12, 13 choose k. So this quantity I want to find out, right?
Right.
So the thing is what so I want k equals to 0 to 13, then only I can apply the formula, right? So what are the extra terms I'm adding? So that is 13 choose 0 and 13 choose 1. 13 choose 13. So these are the two terms I'm extra adding to the summation.
Right. So you have to subtract those.
Right. So this is what you told is 2 power 13. That is correct, right?
No, but isn't the 13 choose 13 the minus 1 from that one case?
No, no, that is gone. That is separate. So this part is separate, right? So minus 12 we have to still do. That is separate.
Okay.
I am trying to find out only this summation part.
Okay.
Right. So from here what I get is 2 power 13 minus 2. That is our answer. This part. Right. So the required number of is, so the required number is 2 power 13 minus 12 minus 12. That 12 will come. So now you have to compute. So 2 power 13 you have to compute. What is that 2 power 13?
Um uh
I
4
think 2 power,
4096. No, not
yes,
4090. 4 8,000 9,000, no, 8,000 uh yeah, 8,190.
right, minus 14 you have to do. How much?
8,100
78.
78, right?
Right. So I think it will work. Yes. So option D, right?
Right. So when can you go back for a second?
Yes, yes. I'll go.
This one
Yes.
for I
Which part?
was very hard. I didn't really I so can you can you can you go to so you basically to make it start from k equals 0, you basically have to subtract k at 13 choose 0 and 13 choose 13.
Right, right. So this summation I want to find out, right? But I only know the formula for this summation. That is when it starts from 0 to 13, that I know is 2 power 13. So this is the only thing I know. So I have
Okay.
to adjust what is the extra terms I have used, right? So that's why I am subtracting.
So 13 choose 0 would be so
1.
that's 1, right? And 13 choose 13 is uh, wouldn't
It is also
wouldn't
1.
no, but isn't it divided by zero? Or
No. 0 factorial. 0 factorial is 1.
oh, right, right, okay, I understand.
Okay.
Yeah,
It's clear, right? Up to till now.
yeah, clear. I just think it would be. I have to get in the habit of doing this because I don't think I would be able to like understand this like or do it if I got it on a test because I'm not very familiar with the summation of 13 to k.
Yes, yes. That you have to. That you have to. Means I will teach you these topics. Then it will be more clear.
Okay,
Okay. So maybe today we'll stop here then. Okay.
okay, yeah. So, is there anything you'd recommend me to like practice? Like, do you have any like practice material or any set website that would?
The thing is, yes. The thing is, you can practice always the previous AMC problems, but the thing
Yeah,
is, you have to learn the topic first. Then means otherwise it is difficult. Means without learning the topics,
right.
so we'll sequentially go through the topics. Then it will be more clear how to apply the techniques you have to learn. Right?
Okay, okay. So when uh okay, I understand.
Yes.
Okay,
Okay. Bye then.
bye.